Okay, so imagine we want to integrate e to the 3x cos 2x dx. We know that there is an identity that e to the I 2x equals cos 2x plus I sine 2x. So if we took the real part of the left-hand side, it would be equal to the real part of the right-hand side. So the real part of e to the I 2x, and the real part over here is cos 2x. If this example here had sine 2x, we would use the imaginary part of the right-hand side because the imaginary is sine 2x. But in this case here we've got cos 2x. So we know that the real part of e to the I 2x is equal to cos 2x. So we can make a substitution for cos 2x. So this integral will be exactly the same as integral e to the 3x does not change. The real part of e to the I 2x dx. We can change the order here. The real part of that will be the real part of those two multiplied together. So the real of e to the 3x, e to the I 2x dx. And we can put the real out the front. When you're multiplying like bases, you add the indexes, so that's e to the 3x plus I 2x, so e to the 3x times e to the I 2x is equal to e to the 3x, add the indexes, plus 2ix. Now x is common in the power, so it can come out the front, so it'll be x outside of 3 plus 2i dx. So I've multiplied them and then just take the factor x out the front. Now the integral of e to the ax is equal to 1 on a, e to the ax plus some constant. If I find the derivative of this, I should get back to e to the ax. When I find the derivative of e to the ax, I'll have an a out the front and they will cancel, e to the ax, and then I'll find the derivative of the constant 0. So I can integrate this now and say that is the real part of e. Now the a would be 3 plus 2i, so it'll be x outside of 3 plus 2i all over 3 plus 2i plus c. And it'll be the real part of all of that. Okay, so once again we can split this up and say the real part of x times 3, so e to the 3x times e to the 2ix by multiplying out using the distributive law, all over 3 plus 2i plus c. Then I can do the back substitution using the identity up above here. E to the 2ix is the same as e to the I 2x, so I'll put a cos and a sine back in for here. So that'll be equal to the real. E to the 3x stays the same. Now, e to the 2ix will be cos 2x plus I sine 2x. Now we'll want to make the denominator into a real number and rationalise the denominator. So we've got 3 plus 2i. And the way to do that is multiply 3 minus 2i. Whatever we do to the bottom, we've got to do to the top. Plus c. Okay. We've got a bit of multiplication to do here now, so we've got the real part. We keep writing that because we want to just take the real part of all this when we work it out. Rationalising the denominator, FOIL, 3 3's 9, outer minus 6i, inner plus 6i, and last. Now 2 times 2 is 4. because there's a negative, you get negative 4, and then I times I is I squared, so you get negative 4, so that'll be plus 4. We've got our plus c here. E to the 3x, now we multiply 3 times the bracket, so we'll get 3 cos 2x plus 3i sine 2x. Then multiply right through by negative 2i minus 2i cos 2x, and multiply negative 2i times a positive I sine 2x. Now the negative times a positive will give us a negative, but the I squared will make that back into a positive, so that'll be plus 2 sine 2x. Okay, a little bit messy up there, but anyway, get the idea. The real, the minus 6i plus 6i gives us a denominator of 13 now. Close the bracket there. E to the 3x. And sort of, let's get the real parts together. So we've got 3 cos 2x. And here is my other part, real part, plus 2 sine 2x. Now I'm left with an imaginary part. I can take I out the front. So there'll be plus I, open brackets, 3 sine 2x. And here's another imaginary part, minus 2 cos 2x plus c. Now, this is always going to be the imaginary part. I could split it up into e to that, and then e to the 3x times that, and that'll be my I part. So the real part is that plus the real part of c. So the real part of that will be equal to e to the 3x, open brackets, 3 cos 2x plus 2 sine 2x. And the 13 could come out the front and make that over 13, plus the real part of c. So, writing it a little bit more neatly, we've got e to the 3x over 13, 3 cos 2x plus 2 sine 2x plus k, where k is equal to the real part of c. Okay, so just in summary, what have we done? We go back up to the top. The trigger is, if we're going to use complex numbers to actually do this integral, we know that we're going to use the identity involving e to the I2x, and if it's cos, we use the real. If this is sine, we use the imaginary. We then do the substitution in, and we keep writing the real part because we're interested in the real part of the whole integral, and then we multiply out. We then use the same identity as up here to do a back substitution. We rationalise denominators if we need to, and then because we're only interested in the real part of that, we discard this because it has got the I. This is the I, or the imaginary component, so we're not interested in that. We are simply interested in the real part of it. We write that out, and because we're also only interested in the real part of C, we write our answer.